Hello, my name is Patrick Gourdet, and this is a little run through my source code and running my program. So we see that it actually functions. These are the libraries that I actually import here. These two imports, the one was the basic testing. The second is the basic testing and test. Training and test. The second is just for testing. Both of them have about 800 different points. In order to give us something a little bit more robust to test against. Here we are just doing some pre-processing measures in order to create matrices in order to be able to read in the data properly or store the data properly. Here we go through the actual pre-processing of the data. We go in here, brings everything to lower, tokenizes, removes stop words, lemmatizes. Here with the Unicode, what it does is actually pulls out any type of codes that may have came through by reading in through the function, and just replaces it with some type of random character. This right here, the text blob, here's where the actual sentiment polarity is actually calculated and then populates the sparse matrix. Here we have the Y vector or Y column normalization, which is then brought to a 0 or a 1. We do the same thing with X, with the actual X matrix. We then separate things between training and test data. Then we start working on our models, logistic regression, and the fit. We print out the training and the test scores for the Gaussian naive Bayes, for the Bernoulli naive Bayes, for the multinomial naive Bayes, for the decision tree classifier, and for the SVC. And for that, we also do the cross-validation scores. Now, if we look over here, the command prompt, I will go ahead and run project one time so we can see that it actually does what it's supposed to. This will take about a good minute, maybe a little bit longer, just because of all of the data that it needs to actually compute. We can actually be looking at that while we're doing that. If we look at it here, this is the entire data set that I actually utilize for the training. This actually goes from 2011 all the way up to 2017. So 6 years of actual data that we are using for this model. And as we can see, this is about 159 different headlines and articles combined. And that's why this is taking so long, because it needs to go through all of that and pre-process it, lemmatize it, use word punctuate, tokenize it. That all takes a little bit of time. Almost done, I would assume. This is probably also one of the better parts once we get to see the outcome. As we can see here, for the logistic regression, it's about 65%. 71 for the naive Bayes, 85 for Bernoulli naive Bayes, 83. Then we have an 85 for the multinomial naive Bayes. We get a 74 for the decision tree. And for the cross-validation, we get a range from 83 up to 85 using cross-validation. Here, cross-validation in the actual decision tree also ranges in that manner. I would like to also show the website that I created. This is an Angular project that I have. This is the basic source code, and right here is the actual website. If we look at it from here, go to the front. This was created for the class as well. This was my timeline. Here are the methods. Some of the results, pre-processing results, basic baseline formulas that were used, some of the results as I was progressing throughout the entire process. We see sometimes it went up, it went down, usually due to the fact that some of the data wasn't necessarily processed properly, or we actually used the wrong stock market index in order to compare against. But in the end, so we actually retrieved something very, very nicely, as we can see here. Once again, logistic regression was about 64. He was about 73. And Bernoulli was about 87. And it's kind of ranges exactly around this area continuously. Here we have the basic source code. This is the first source code that I actually started with. And that would be the website that I created for this project.